this problem, y equals 4 minus x. So that's just the line with the slope negative, and the y-intercept is 4. So we're going to come down like that. The next one, y equals 1, which is the horizontal line. X equals 0 is the y-axis. We rotate about the x-axis. Put all the graph together. Start with the horizontal line, so y equals 1. And y equals 4 minus x, so gonna be intercept at 4 and go down 1 over 1, down 1 over 1. 1, 2, 3, 4. And x equals 0, which is this one. Now, looks like we have the triangle. We know that the graph crosses at the point y equals 1 here and y equals 4. And how about this one, where the line y equals 4 minus x and y equals 1 meet each other? So we find this intersection point by 4 minus x equals 1. Then x equals 3. That's an algebraic way to find it. Okay, that's the intersection point. Now we're gonna rotate this region about the x-axis, and the x-axis, this is going to be the axis of revolution. You rotate this way. Okay, the axis of revolution is the x-axis. When you form the partition or the bar will be parallel to the axis of revolution for the shell. This bar, you see the position here, that's the position y, because it's laying down on the y-axis. Once you see the y position, you can tell that the thickness gonna be delta y or dy. And when you move the bar up and down, the lowest y that it can go within the region gonna be 1. The highest y it can go gonna be 4. So we now have the interval of integration. Okay. Next, perform the revolution to see how the shell gonna be. So we have the shell that wrapping around the axis of revolution. We're gonna need the radius and the height of the shell. The radius will be found by measure from the axis of revolution to the position. Okay, to the position. And in this case, the axis of revolution on the bottom, the position is on the top. So the radius can be found by using the top part minus the bottom part. The top would be y, the bottom would be 0. Okay, the position y minus position 0, or just the y. Okay, so this is the top and bottom. Okay, we got the radius. Next, we're gonna find out what is the height of the bar. So that's the height. Okay, this time the height is kind of, you have to measure from the right end to the left end. So the right end of the bar is on the line y equals 4 minus x. Okay, this is the right end, and the left end is the line x equals 0. Think about this. This problem is involving y. So you're going to do with respect to y. Every function has to change in terms of y. So for our case, the line y equals 4 minus x, it becomes x equals 4 minus y by rearranging the terms. So I'm going to do it in the more detailed version. So it's going to be y minus 4 equals negative x, or x equals 4 minus y. Okay, that's another form of the line on the right side here of the region. The height gonna be the right function minus the left function. And the right function is 4 minus y. The left function is x equals 0. So gonna be 0. Therefore, the height is 4 minus y. Now we get all pieces. So I'm gonna highlight. So we have dy as the thickness, we have the interval, we have the radius, and we have the height. That means the volume can be set up as 2 pi as the coefficient, integral from 1 to 4. The radius is y. The height is 4 minus y. The thickness is dy. So that is the radius, that's the height, and that's the thickness. Or 2 pi integral from 1 to 4. Distribute y into 4 minus y to be 4y minus y squared with respect to y. The rest, same routine. Antiderivative of 4y is 2y squared. Antiderivative of y squared is y to the third over 3. Evaluate from 1 to 4. 2 times 4 squared minus 4 to the third over 3. And then subtracted by 2 times 1 squared minus 1 to the third over 3. Quick calculation here, you will get 18 pi as a result.